India's premier space research organization's calendar for 2022 looks very busy. And NewsX, as part of its special cover story on the second spaceport, we have with us ISRO Chairman S. Somanath. Sir, thank you so much for joining and speaking to NewsX. We are doing some ground reports and looking at the developments as far as the Kulasekarapatnam spaceport is concerned. As of now, where does the project stand, sir?
This project is currently in the land acquisitions phase. We need to have 2,500 acres of land, very close to the sea. Yeah. And the launch point will come somewhere middle of this. So we need to give sufficient space for safety consideration. So that's why this much of land is needed. So right now, almost 1,000 acres land has been acquired, but then remaining land is to be acquired. The process is on. We believe some few months we can complete it.
Yeah, I saw when I was waiting for you, Vikram Sarabhai book, and he was the one who initiated the Sriharikota from brick to what it is today. So you will be also part of history, a legacy that you are going to create. What does this project envisage?
Okay, coming to the legacy, of course, we are all part of it. It is what we are enjoying today are the work of many generations of people. Yes. So we salute all of them. Yeah. And this particular launch site, Kulasekarapatnam, has been something that we have been considering, discussing for many years. At least now there is an action to acquire the land and then build this launch port. Probably you know that why this launch site, the Sriharikota has its own advantages because it's an island and very less inhabitation, and then we have a huge safety margin from the launch port to the habitated area where this is an essential requirement. Right. But it has its own disadvantages. The disadvantage is that if you have to launch towards south, then you can't go straight because Sri Lanka is there. We conduct a dog-leg maneuver. We go a little bit towards the east, then take a turn towards the south, and so this whole process maneuvering reduce the payload of the given launch vehicle. Right. So PSLV also lose payload on this account. Yes. So then we looked at why not we launch directly southward from the southernmost point or somewhere near to it. That is the reason for identifying Kulasekarapatnam, and it has an advantage specifically for launching towards south and may not be a suitable launch site for launching towards east. So that's why it is chosen.
There are a lot of advantages. When can we actually see the realization of the second spaceport?
See, I am just telling that the land acquisition will run in another few months. After that, we need to start the construction process. We have already a project of how to build this has already been cleared. And the design of those launch pad, the facilities, infrastructure requirement are all being detailed. So now after the land has been acquired, we need to place a peg where it is going to be. So do a survey of the land, its terrain, then find out conduct the necessary measurements at that location, like the soil and that example, the leveling, then load bearing capacity estimation, which will run for a few more months. After that, we do the detailed design of the launch pad, the jet deflector, and things like that, which will come there. Then design the buildings to suit the terrain.
Okay.
So this process will run for further few months. After that, we have to tender it out, the construction of this, which may last at least something like 18 months to 24 months of time. After that, we will be able to launch.
So about roughly around 2 years,
2 years plus, because 2 years is only after starting of the construction to realization. Right. 18 months to 24 months. But the initial process, I believe it will take another 10 months or so.
All right. So once the second port is ready, spaceport is ready, the traffic will be diverted from Sriharikota. What are the kind of traffic we'll see in this port compared to the new one?
See, this port can handle only small class of launch vehicle. It cannot handle huge class of launch vehicle, primarily because of the safety considerations. See, typically from where the rocket is launched to the nearest inhabited place, we need to have a distance of at least 5 kilometers. For that, 2,500 acres is not enough. It has to be much bigger, but that land is not there at this place. So we have to limit the danger zones and correspondingly the size of the rocket. Why still this Kulasekarapatnam is there is a new class of rocket which has come that is called the small satellite launch vehicle, and there is an emerging market for small satellite launches. So for this, we have now developed a SSLV, and this maiden flights will be from Sriharikota, but its payload capability cannot be fully exploited if we launch from Sriharikota, because this rocket has to make the dogleg maneuver.
Correct.
But if you launch from Golasekharapatanam, then its payload can be, the full capacity can be enjoyed. So this launch pad is specifically designed for two things. One is to launch SSLV or any future small launchers which are likely to emerge in this country. Probably, there are many startups working in launcher area, and all they can go to this new launch pad, and for a mission that demand launched in southern direction, they can directly use them.
So that's where the in-space come, and that's where there is future for in-space.
Correct.
What are the developments around in-space? That's a conglomeration of government as well as private entities coming into. The future is the sky's the limit. So
currently we are looking at how we can engage private entities more into space program. If you have to develop the economy of space sector, the only way that the investment has to be from private sector. And they won't just like that invest. They need to see a business plan. So we are trying to see how we can engage with the space industries in India into space ecosystem to develop a business plan and develop corresponding elements. The elements are, one is rockets, spacecrafts and applications. So in this sector, currently there are startups and also established companies. Established companies are doing currently the space-based contract development or building for ISRO already. Our rockets are built in industry, so they are going to take up the next level of taking over those building of this rocket on their own, using the IP or knowledge from ISRO. And another thing which is happening is the startups, at least some 50 startups are there, 2, 3, 4 in launch vehicle, some are tens in satellites and remaining in application sectors. They have reasonably good funds to kick off the work, but then more funds need to flow into them. They need to harness a little more technologies and develop their first of rockets. And similarly, satellites also, they are trying to develop the first of technologies and then build those small satellites. Into application segment also some people are coming. Now this area has to become a business the system. There must be money flow and profitability. So this is I need yet to see this, but then at least there is a starting. With this starting, we hope that slowly these people will find their markets. There is a huge market. There is no market like India available in where there is a.
My question stems from the fact that what Elon Musk has done to US. There's a lot of chat amongst the youth in this country. They also want to do something. In the last 10 years, he's catapulted himself to the position that he is now, talking about giving internet from satellites, and the scientific temperament is discussing these things, especially in the younger generations.
See, let us not jump into conclusions that Elon Musk is in US and we will have another set of Elon Musks here. I think I have no.
You want to be more practical?
No, I am a paka practical person, and I would like to see that. There is a substantial growth in space economy and activity in India. I will only limit to that. See, the Elon Musk is happening because of various reasons in US. There was a decline in space program in ISRO. In NASA because of space shuttle retirement, and there was NASA was creating Elon Musk primarily to create the industry-funded launch vehicle development and human flight development in private entity to happen. So it was a strategy adopted by NASA to overcome the problem of governmental funding. So correspondingly, such people emerged. It's not only Elon Musk. There were established players like Titan, Atlas. There were so many launch vehicles already in private domain in US.
Spacecraft, basically.
Launch vehicles were there. Spacecrafts were built by Boeing and so many other people. Lockheed Martin also built spacecrafts. So compared to India, there is an established private players in US. Okay, but when you talk about India, the problem we are facing today, there are no established space players in India, industries. Though there are big industry houses, none of them found space an attractive domain at all. To create investments of thousands of crores, to create a business opportunity around space sector. What you are seeing today is an interesting thing that they are now slowly seeing the future. Big business houses are seeing the potential that space can still be an economically viable proposition.
Yes.
So only
that's largely the Indian philosophy of ISRO, where we always look at the economy and how to reduce the cost.
It is like that only. See, business will grow only if there is a profitability. No businessman will invest to make a loss. Elon Musk also is not invested it to create a business possibility.
There was a very famous line. The cost of Chandrayaan 2 was lesser than the movie which costed the Gravity movie which they made in the US.
Definitely, because in India we do everything very frugally. Our engineering way of doing things and doing is always frugal. But in private companies, when you do it in India, it may also turn out to be similar. I don't have any doubt about it. That's not the topic we are discussing. The discussion is on how a high-level space economy will come in India through private entrepreneurs. This is a question. So if this has to happen, the business houses have to see potential in this.
Right.
Say, for example, when you see there is a huge amount of market in communication infrastructure, in launching their own spacecrafts, carrying out the communication infrastructure through supporting it through the space-based services, they will invest in building satellites.
Right.
And when they invest in satellites, they will build the corresponding ground infrastructure, which will generate huge amount of business opportunity.
Right.
And similarly, they may also find it economical to launch their own rockets for their satellites. Then huge satellites will be built here. Rockets will be built here.
Yeah.
Similarly, if they are successful in bringing foreign satellites for launch in India in a commercial manner, then this sector will grow.
Do you think this conversation is right now happening in Space Committee, wherein private players are also interested to be a partner with ISRO?
They are already there. See, there are a lot of proposals in space currently. They are discussing, their board is discussing. They are all small proposals. See, currently they are looking at developing certain rockets. They are looking at some mechanisms. They are launching some experiments like that. But we are facilitating that discussion.
Yes.
We are enabling them to develop that through the support of ISRO technically. The infrastructure in ISRO will be shared for them to take up that work.
Yeah.
But they are all baby steps today.
Yes.
What we need is a huge step.
Giant
step. Now, for that to happen, of course, these baby steps must become successful.
Right.
It should demonstrate to the public that the confidence in working in space sector in private industry is still possible. So, what our goal today is to demonstrate to the community, yes, the startups are going to be successful. It will be possible to develop rockets in private sector in India also.
Right.
And it is possible to develop satellites in a private lab in India and then still achieve certain useful missions.
Right.
If you demonstrate it, then the big players will pitch in.
Yeah.
And then there will be a sudden change in the economy or the ecosystem.
So the hesitancy will go away.
So our current
right now they see space as a big black hole where they lose a lot of money.
Everybody will have the fear.
Yeah.
See, let us understand that launch vehicle business, for example, rocket design and development, is a high risk business. You invest thousands of crores and the first launch it fails. Second launch it fails. Then third launch you will not have money left to launch.
Right.
So whether you will be able to recover that cost and still go forward. You read the story of Elon Musk. You will understand that he went through failures because he had enough backup. And so he could come back and then succeed in the subsequent launches. And once you are successful, everybody forgets about the failures.
Right, sir. So, talking about ISRO's calendar this year, looks like very busy. What are the main events that the country is looking forward? ISRO is looking forward this year.
See, we have a mandate to launch certain spacecrafts today, which is looking from the user side. We have launched one radar imaging satellite recently using PSLV. We have another ocean observation satellites, again a user-demanded satellite to observe ocean. There are departments of Government of India looking at it. So we are getting ready with the satellites to be launched again using PSLV.
Yeah.
Then we have small satellite launch vehicle, which I mentioned sometimes back. Which has its maiden launch has to happen this year. And after that, 2 more launches we are targeting to happen this year. So 3 launches of development of SSLV must happen. We have to have the GSLV, there was a failure in the last mission. Right. We have identified the failure. After correcting it, we have to have the launch. Launching a navigation satellite to support the NavIC constellation system and launch its remaining NavIC satellites, which are already in the process of realization. We have 2 launches of Gaganyaan related mission.
Yes, that's
that one we want to look at how the Gaganyaan mission abort sequence.
These are unmanned.
No, this is to demonstrate the abort sequence of the mission.
Okay.
Because before we send anybody to up there, we must first demonstrate we can save them.
Right.
So saving part is the first demonstration.
Yeah.
So we have a test vehicle, which is a liquid engine based vehicle, and that test vehicle will be launched with the crew module and the abort system, and we will intentionally abort it, and then show that the abort sequence work, and then we are able to recover the crew module safely. This will also be repeated this year. We want to do 2 times and show that the abort system is working well.
So when is the manned mission, sir? The training is over apparently, and we are preparing for that big event.
That I can't comment on the date of the manned mission. I can only say that it is an event that will sequentially happen, because many steps are to go towards a human space flight mission.
Yes.
When you send somebody, especially from India, we want to make sure they will come back, right?
Yes.
So if you want to make sure, then we need to take all those steps which will give you the guarantee, and also the guarantee to the public also, and also those people who are going to take that risk of flying, that we are in a position to bring them back.
Yeah.
It requires a very carefully calibrated engineering decisions as well as tests and demonstrations.
Right.
So what I mentioned just now is the first step of them. We have developing the crew module, we are developing the abort system, we are developing the intelligence in the rocket to understand there is a failure going to happen and abort it. So these 2 will be demonstrated first. Followed by that, we will be conducting an unmanned mission in the full vehicle GSLV Mk3.
Okay.
And after this, assessing all this flight data, then we go for a second unmanned mission with a little more features in that. For example, in that second mission, we will include the real crew environment, environmental life support systems, and we have to test all of them work well in the mission.
Right.
And then after that, we will be taking some more abort missions, because we have another 3-4 abort missions which will happen overlay with this unmanned missions.
Yes.
And after analyzing all these 7-8 missions, then we will take a view on the final mission. So it is not one launch that put a man.
It's a sequence that has to go one after the other.
And one second one will be a result of the first one will go into the second one. Right. So we have to make incremental progress.
Right. So you are going to draw inferences from each of these launches and then improvise it.
Correct.
All right. Chandrayaan is most eagerly awaited. Is Chandrayaan 2 still giving output? What about Chandrayaan 3? We're supposed to see the launch in August.
Yeah, Chandrayaan 2 is still working. Today also we had a review of the Chandrayaan 2 and how we can make some data available for science community. It's excellent way it's working. The data is still coming to all the science community. Chandrayaan 3 is in the building stage. Currently we are in the testing the module in the propulsion system, because we the last time we had a problem with that.
The last thrust was lost. Yeah.
So to overcome that, there is a change in the propulsion system. The propulsion system is undergoing testing at Sriharikota, at Liquid Propulsion Center at Mahendragiri, as well as in a new test facility we have established at Sriharikota in the suspended hanging condition, demonstrating the landing sequences. So it is an integration of propulsion plus the computer and sensor system undergoing the testing. The results are really good, and every night there is some test going on nowadays.
Fantastic.
So we will analyze the test data. Meantime, the satellite building has nearly reached a final phase. But before we decide to launch, we would like to look at all the test data and analyze the software, the hardware. And I want to tell you plainly that we would like to go very, very cautiously this time, because we know how to go to moon is well proven.
Yes.
The only thing that we need to prove is how it lands, and it has to be error free, the best of our abilities, and all test program recommended through the previous recommendation committees, etc. we want to do. And of course everything is not smooth.
What was the critical issue that you learned in the last landing, sir? Where did we go wrong, and how is the improvisation this time? If you can put in layman's language.
Yeah, I will put it like this, because we are trying to land in Earth itself is difficult. There is atmosphere, the gravity effects, etc. The rocket is such a thing that you can never test it in the real environment at any point in time. When you build a rocket, the first time when you launch, it is never launched before. It is launched only in a computer.
Right.
Suppose you take a car. Before the car is launched, it would have run thousands of kilometers without hiding its real face. You paint it in a different color and run through across India, different terrains, and prove it that the engine, the suspension system, everything is working very well. After that, the company makes a huge, grand announcement of launching. For a rocket, is it possible? It is simply not possible. The very first time it will see that rough terrain when you actually takes off. Now look at Chandrayaan 2. we have never gone to moon and never gone and experienced the type of gravity field of moon in Earth, and we have never navigated on a surface where you have to identify the location where to land through sensors which you have put in that. And we are not actually measuring it. They are using certain type of sensors to measure altitude, elevation, speed, etc. And looking at camera and imaging the surface and identifying this is the place to land. So in all this, there are limits of errors. And we test all these systems.
And too many variables.
And variable has its own bounds. So in technical terms, you say lower bound and upper bound. If any bounds are exceeded, your algorithm, the software which is sitting inside, malfunction. So such a malfunction really happened, that your threshold of working limits, bounds on which it has to work has exceeded. So then software has its own problem. So this is what we are trying to correct in the subsequent missions, how we can look at a complex system with autonomy. The whole craft is now autonomous. You know, autonomous cars which will drive in the
the Google cars that we see.
They are just coming. Now they are not yet come to the market. We are talking about Chandrayaan 2 fully doing an autonomous landing. You think
challenges
it is much more challenging. No, here in Earth at least it is standing. Even if you put apply brake, it will stop there. But what will happen to Chandrayaan 2 when lander, if you apply brake, it will simply fall down. So it's a really complex problem of hardware and software and algorithm and ability to foresee the unknowns. Of course, our error was in terms of our bounds of errors were exceeded. So this is what we understood, and we need to strengthen both the hardware and software.
When you talk about your reusable launch vehicles, this will actually cut the cost of entire operations of launching a rocket. Where are we and how are we progressing on that?
See, our reusable rocket is not meant for cutting down the cost. What we are working on. The reusable rocket, we have two classes of reusable rocket. The winged reusable rocket and an expendable rocket recovered. So I'll give an example like this. The winged reusable rocket is like space shuttle. The space shuttle was one of the costliest reusable rocket in the world. So reusability doesn't mean it's always cost reduction. The winged reusable rockets are used in the upper stages. And it is recovered because the payload inside is much more valuable than the rocket itself. So it can bring a spacecraft back from orbit. It can take human beings to a space station to construct something. So it is designed for a specific purpose of reusability. Whereas the lower stages of a rocket, if you are recovering through retro propulsion and vertical landing as SpaceX does, you can reuse it and then bring down the cost. So reusability has two elements. Bring down the cost if you recover the lower stages. Bring down use for a specific purpose if you bring the upper stages. Currently we are working on upper stage recovery using winged craft like what is done in space shuttle. Here we will be able to launch a craft in the orbit, do some experiments, deploying it or doing some strategic missions or something, and after that it will come back and land. So currently we are working on a landing demonstration. After that we will be going to the orbit. We have plans to look at the lower stage recovery also, vertical landing demonstration. So this is a new project we are now currently envisaging.
Sir, last question before I let you go off. The ISRO is the pride of the country. And last time the Prime Minister was here. This was quite an emotional moment for your former chairman also. How is ISRO gathered itself and how are you bracing for the challenges? How is the atmosphere, especially after you taking over as the new chairman a couple of months ago?
See, we had an excellent years when the last chairman was here. We had many new programs approved, which includes our continuation program of the projects, the reusable launch vehicle, the air breathing propulsion system, new satellites were approved. But then the last year, 1.5 years, there was a new change of vision, which is nothing but the reform process in space sector. So the reform process has brought in new challenges in front of us and new opportunities. So this is what I am going through now. After coming to this seat, I looked at the reform process, how we can make it happen. This is the agenda for me. Government has announced the reforms, but as Secretary of Department of Space, my responsibility to implement it. So here the implementation happens only when we do certain groundwork. What are the groundworks? Essentially, you have to bring down policies. First time, my goal is to bring down the space policy of 2022, which is currently drafted and it will be released soon after due approval. After that, we have to put up a space act, space bill in front of the parliament so that we can enact it so that private enterprises, entities, when they do space activity are governed and controlled, regularized and authorized. This is the second step. Third step is in-space has to become fully operational. So that was my work in the last 1 or 2 months, working with the in-space chairman, their board, and also staff it, establish its operational centers, start working with the private entities, and then engage them with ISRO activities. So this is we could do at least 40 such proposals came, and in-space was successful in dialoguing with the ISRO centers and engage this activity further. Next milestone is to see that in the coming years, the COVID is now subsided. Let us see how we can ramp up the production of launch vehicles and satellites. And as I mentioned earlier, how this coming year's launch manifesto can be substantial, so that we show up that there is a good work going on, so that our industries, partners, they have enough of task at hand. And we also meet the national demands for making our launches and satellites, which are already committed, how to achieve it in a very short point of time. Lastly is to create a vision for at least for next 20-30 years of time. So space sector, with the reforms, the vision also changes. There are tasks which are responsible. ISRO is responsible. Department of Space is responsible. We are also looking at what all tasks which we have been doing so far can be done in an industry ecosystem, so that the space economy is growing. So we have framing our own vision document in the coming days, which will be again discussed at appropriate for announcement.
Your answer actually tempts me to ask one last question. Academia, don't you think it's high time that we bring in more of space programs, LOI, in the engineering courses, push for it and get industry partnership also into it?
We are already doing it. We have already a capacity building program office here with a director. He is looking at establishing various centers, units, incubation centers, ecosystems in Institute of Higher Learning. And we have good funding for all these people to do joint research activities. So this is currently it is going on, and we continuously engage with academia for specific research topics. Last month we have announced a respond basket in which all the research problems that ISRO wants to look at it by the academia has been already announced in our site, and many of them will come to us now with the proposals, whether professors or institutions or students who want to take up some of the research topic. We will review internally and fund it over a period of time, and review regularly and then take up this. So this activity is going on, and we also have space projects or space programs starting at some universities. 2 weeks back we have announced, 2 or 3 weeks back I believe, announced a Satish Dhawan Space Science Center at Jammu University, Central University of Jammu, where they will be starting a new program on course in space science and technology, and students will be enrolled as part of the university, and we will be supporting from the ISRO's institute, that IAST at Thiruvananthapuram. We will collaborate with the university in Jammu. So Jammu to Trivandrum connection also we made. A minister of our space minister of state has announced this.
Yes.
So a lot of activities are going in this direction.
All right, sir. I wish you all the best for your chairmanship and also the calendar of events that's going to unfold this year.
Thank you.
That was ISRO chairman
JP
S. Somanath talking to NewsX, giving more details on the spaceport.
Thanks a lot, JP. It's a big thank you to Chairman Somanath for getting into that deep dive with us. And JP, thank you very much for really going into it over a proper 30-minute conversation. Not just surface touching everyone.
For more such videos, subscribe to the NewsX YouTube channel, hit the bell icon.